Before dawn on July 16, 1945, the world was one way. The desert was silent, untouched, and the air was thick with anticipation, as if the earth itself was holding its breath. At exactly 5:29 a.m., everything changed. In a single instant, the course of history was forever altered. In the Jornada del Muerto desert, a countdown reached zero. Scientists and soldiers braced themselves, knowing they stood on the edge of the unknown. For a moment, there was silence. Time seemed to freeze, and every heartbeat echoed in the stillness. Then a flash brighter than 1,000 suns erupted, light not from our star, but from our own creation. The darkness was shattered by a force never before seen on Earth. This was the Trinity test, humanity unlocking the elemental power inside the atom, a secret hidden since the birth of the universe. The atomic age was born, written in fire and thunder, its arrival impossible to ignore. A wave of heat followed, felt miles away, scorching the desert and searing itself into memory. A colossal fireball climbed into the sky, morphing into the now infamous mushroom cloud, a symbol of both awe and dread. The ground trembled as the roar of the world's first atomic explosion reached stunned onlookers, the sound arriving seconds after the light. Imagine being there, scientists and soldiers, awestruck, realizing they'd unleashed a cosmic force. Some cheered, some were silent, all were changed. Oppenheimer recalled, "Now I am become death, the destroyer of worlds." His words echoed the gravity of what had just occurred. This was more than an explosion. It was a shift in the balance of power on Earth, a moment that would shape the destiny of nations. Humanity now had the ability to cause its own extinction, to wield destruction on a scale previously unimaginable. The energy released equaled 21,000 tons of TNT, a force so immense it defied comprehension. But the true impact was the invisible poison, radiation, that lingered long after, seeping into the land and air. The desert sand fused into a new glassy mineral, trinitite, a permanent scar on the planet, a reminder of what was unleashed. The world had changed forever. There was no going back to the innocence of the night before. The atomic fire could never be put back. Its shadow would stretch across generations. The dawn of the nuclear era had arrived, and with it, a new chapter in human history, one filled with both hope and fear. How did we get here? What chain of events led humanity to the brink of a new and terrifying power? The story begins not in a lab, but in the restless minds of scientists probing the universe's deepest secrets, driven by curiosity and a desire to understand the unknown. Early 20th century physicists discovered that atoms, the building blocks of matter, held immense, almost unimaginable energy locked within their tiny nuclei. Einstein's famous equation, E=mc2, revealed that mass could be converted into energy, potentially a staggering amount of it, far beyond anything previously conceived. In 1938, German chemists Otto Hahn and Fritz Strassmann split a uranium atom, achieving nuclear fission. The news electrified the scientific world and sent shockwaves through the global community. Scientists quickly realized that a chain reaction could unleash energy on a scale never before witnessed, opening the door to both promise and peril. Suddenly, the atomic bomb was no longer a work of science fiction, it was a looming reality. This scientific breakthrough arrived just as World War II erupted, plunging the world into chaos and uncertainty. Nazi Germany was on the march, and many of the world's top physicists, many of them Jewish, had fled Europe seeking safety in the United States and the United Kingdom. Allied scientists feared that Hitler's regime might harness this new power first, giving the Nazis an unstoppable advantage. The fate of the world seemed to hang in the balance, as leaders and scientists grappled with the implications of this discovery. In August 1939, physicist Leo Szilard and others persuaded Einstein to warn President Roosevelt of the potential for a German atomic bomb. Einstein's urgent letter urged the US government to begin nuclear research, fearing that German advances could tip the scales of war. This letter became the catalyst for a new era, setting off a chain reaction of its own. It set in motion the race to build the most powerful weapon ever conceived by humankind. The Manhattan Project was born from this spark of fear and possibility, gathering the brightest minds in secret locations. Science and war had become inseparable, as military urgency fused with scientific ambition. The countdown to Trinity, the world's first atomic test, had begun, marking a point of no return. The world would never be the same. The spark of an idea had ignited a fire that would change history forever. Roosevelt acted. What began as a small committee became the Manhattan Project, the largest, most secret scientific effort in history. Its goal: build an atomic bomb before the Nazis. The project united Nobel laureates, young geniuses, and engineers under J. Robert Oppenheimer at Los Alamos. Oppenheimer inspired and managed a team racing against time and uncertainty. The technical challenges were immense: finding the right fuel, rare uranium-235 or newly discovered plutonium. Massive factories at Oak Ridge and Hanford produced these materials at breakneck speed. Tens of thousands worked in secrecy, most unaware of the project's true purpose. At Los Alamos, scientists invented the bomb from scratch, pursuing two designs: a simpler uranium gun type and a complex plutonium implosion device. The implosion bomb would be tested in the New Mexico desert. It was a gamble unlike any before. The stakes were global, the clock was ticking. The world held its breath. The outcome would change history. July 16, 1945. In the pre-dawn darkness, the plutonium bomb, ominously nicknamed the Gadget, sat atop a lonely steel tower in the barren New Mexico desert, waiting for history to unfold. Thunderstorms rolled across the desert, threatening disaster. The test was delayed, and with every rumble of thunder, tension mounted among those gathered. Scientists and soldiers huddled in bunkers, exhausted from sleepless nights and anxious about the unknown power they were about to unleash. Would it work, would it fail, or would it succeed beyond their worst fears, changing the world forever? Oppenheimer chain-smoked, nerves frayed, while General Groves focused on logistics, determined to keep everything under control. Time seemed to crawl. At last, the weather cleared. The countdown began, each second stretching into eternity. At exactly 5 hours, 29 minutes and 45 seconds a.m., the Gadget detonated in a blinding instant. The flash was so intense it blinded observers, visible from 150 miles away, lighting up the desert like a second sun. The heat was searing, burning faces and arms even from 10 miles distant, a sensation none would ever forget. The shockwave thundered outward, knocking men off their feet and shattering windows in distant ranches and towns. The mushroom cloud rose into the sky, a new and terrible symbol of human power and fear. Some scientists cheered in triumph, but others felt only dread and uncertainty about what they had unleashed. Isidore Rabi later described a chill that was not the morning cold, but something deeper, a shiver of the soul. Kenneth Bainbridge turned to Oppenheimer and said, "Now we are all sons of bitches," capturing the moment's gravity. In that moment, they understood the true weight of what they'd done, and the world they had changed. Humanity had crossed a threshold that could never be uncrossed. The genie was out of the bottle and there would be no turning back. The world would never be the same. The dawn of the atomic age had arrived, forever altering the course of history. Trinity's success changed World War II's course. Facing a costly invasion of Japan, President Truman saw the bomb as a way to end the war quickly. On August 6, 1945, the Enola Gay dropped Little Boy on Hiroshima. 70,000 died instantly, tens of thousands more from burns and radiation. 3 days later, Fat Man was dropped on Nagasaki, killing another 40,000 instantly. Japan surrendered. World War II ended. But the bomb's use opened a Pandora's box of moral questions. Scientists who built it were horrified by its devastation. The joy of discovery was forever tainted by the reality of its power. The mushroom clouds ended a war, but cast a shadow over the future. The US was briefly the sole nuclear power, but the Soviets soon caught up, testing their own bomb in 1949. The nuclear arms race began, dividing the world by nuclear capability. The Cold War was a standoff between superpowers, each armed for mutual destruction. Mad. The logic of MAD didn't stop the arms race, it fueled it. The hydrogen bomb, thousands of times more powerful, escalated the threat. By the 1960s, arsenals could destroy civilization many times over. Humanity lived with the constant fear of nuclear apocalypse. Duck and cover drills, fallout shelters, and the Cuban Missile Crisis brought the world to the brink. For 13 days, a single miscalculation could have meant global destruction. The world survived, barely. The nuclear shadow lingered. Our survival depended on a fragile balance of terror. The arms race meant not just building bombs, but testing them. Over 2,000 nuclear explosions from the 1940s to the 1980s. Atmospheric tests sent radioactive fallout around the globe, contaminating air, water, and food. Strontium-90 and other poisons entered the food chain, causing cancer and illness worldwide. Communities near test sites suffered most, downwinders in the US Southwest, islanders in the Pacific. The Castle Bravo test in 1954 contaminated entire islands, forcing relocations and causing generations of sickness. Test sites became some of the most contaminated places on Earth. The environmental impact was profound. Ecosystems destroyed, landscapes scarred. The long-term effects are still not fully understood. The legacy of nuclear testing is a poisoned inheritance. The invisible wounds of the nuclear age remain with us. As fallout dangers grew, a global movement for control emerged. Scientists and citizens protested, fearing extinction. The Cuban Missile Crisis forced superpowers to negotiate. The 1963 Partial Test Ban Treaty banned atmospheric, space, and underwater tests, reducing fallout. The 1968 Nuclear Non-Proliferation Treaty limited the spread of nuclear weapons. Strategic arms treaties between the US and USSR reduced arsenals. These agreements weren't perfect, but they created communication and transparency. Norms against nuclear use and spread took root. The end of the Cold War brought further reductions. The immediate threat of global nuclear war receded. The world breathed a sigh of relief. The doomsday clock moved back, if only for a while. 80 years after Trinity, we live in a world shaped by its legacy. The bomb ended one war, started another, and introduced the fear of instant annihilation. It poisoned the environment and left a legacy of sickness. The threat remains. Thousands of nuclear weapons still exist. More nations have joined the nuclear club. The risk of nuclear terrorism persists. Regional conflicts could still escalate into nuclear war. The doomsday clock ticks closer to midnight. What have we learned? Science is powerful, but morally neutral. Responsibility lies with us all. Our world is interconnected. Nuclear war anywhere would devastate everywhere. Diplomacy and cooperation are the only rational paths forward. Trinity's legacy is dual, a warning and a testament to restraint. For 80 years we've avoided nuclear war, barely. The challenge is to continue reducing arsenals and fostering peace. The fire lit in the desert can destroy us, or guide us. The choice is ours.